This is a quick screencast on time series plots. A time series plot is one in which a univariate set of data is plotted against time or observation number. Time series plots can reveal interesting trends or data collection issues. And typically, when univariate data is collected, a lot of people just kind of analyze the univariate data, but they fail to kind of look at the results of that data as a function of observation number or time. In other words, the time at which the data was collected. Time series plots can be considered bivariate data because time is one of the variables. And I think this will make a lot more sense when I go through a couple examples. So here we have an example of the temperature, maybe of a particular bioreactor. I'm in chemical engineering, biological engineering. So this example is looking at perhaps cell growth for pharmaceutical companies. So we've got a bunch of experimentally collected temperatures here. And if we just make a nice histogram showing the frequency of different temperatures as a function of the bin center, we sort these data into different bins, and this is what we get. Now, if you looked at this as a time series, so if we look at not only the temperature, but the hour during which the sample was collected, and if we plot temperature on the y-axis and time on the x-axis, we can see that this is a nice time series plot. Analyzing data in this way, we can see that there are a couple data points here around 18 hours, 19 hours in which our temperature dropped below an average of around 37 degrees Celsius. So time series plots allows us to kind of see and identify interesting phenomena that might happen over the time course of data collection. Another example here, we have temperatures here, same sort of example. If we plotted these as a histogram, we have a nice distribution here that appears to be normally distributed, or a bell curve. However, if we plotted this as a time series, we would see that over time or during the data collection phase, we're actually seeing a decrease in the temperature. So it's starting out around a little bit above 37, but over the time course of the data collection process, we're seeing that the temperature is decreasing. So, if this were cell growth, then I would be concerned because the reactor is getting colder over time. So even though our data might look nice and normally distributed, if you plotted this as a function of time or observation number on the x-axis, then you can identify interesting things.